Hey, Ami girl. I got a call saying that negative exponents were coming up and that maybe you could use a video. So, hope this helps. Anyhow, negative exponents, they are a teeny bit confusing, so let's talk about them. Negative exponents. Okay, first of all, I know you know what exponents are. If I were to say something like 3 squared, you would know that's the same as 3 times 3, or 3 to the 5th, that's 3 times 3 times 3 times 3 times 3. An exponent is just telling you how many times you're going to take that number times itself, right? Right, absolutely. Well, where does that start? Does that start at just a 3 to the 1, and that's just a 3? Because we don't typically write that 1. We don't typically write that. We would just write 3. Huh. Well, actually, this is funny. We could write 3 to the 1st if we wanted, but we don't, because that would just be 3 to the 1st. That would be like, let's see here. If we have 3 to the 1st, then we could go to 3 to the 2nd, and then we could go to 3 to the 3rd, and that would be like going to 3 times 3, and then going to 3 times 3 times 3, and going on and on and on, right? 3 times 3 times 3 times 3 would be our next one, right? What happens when we go the other way? What's this? Well, this is when we start dividing. Because if we multiply this way, then we're going to start dividing when we head the other way, okay? So that gets a little bit funky and it seems a little weird, and the weirdness starts with 0. So we're going to start at 3 to the 0. 3 to the 0 is 3 over 3, which is 1. So here's the weird rule. Any number to the 0 power is always 1. Any number to the 0 power is always 1. Always. Because you're dividing something by itself. And when you divide something by itself, it's always 1. Okay? Always 1. Period. Exclamation mark. End of story. Period. There we go. I'm so funny. All right. So now let's go past 0 and let's go into those stupid negative numbers. What happens when we do a 3 to the negative 1? Okay, we've already divided it once, remember? And when we divided it once, we got 1. Okay? So we've already got a 1, and now we're dividing it again by another 3. Okay? So when we have an exponent that's negative, what it does is it pushes that number into the denominator. Pushes the number and its exponent into the denominator. So we could put a little 1 right there. There we go. 1 over 3 to the 1st. Okay, so a negative, let's put this up here, negative exponents. Push the number and its exponent into the denominator. That's what that does, okay? So, for instance, if we had 3 to the negative 2, it's the same thing as 1 over 3 squared. Same thing. 3 to the negative 5th is the same thing as 1 over 3 to the 5th. 3 to the negative 7th equals 1 over 3 to the 7th. I think you see where I'm going. X to the negative 2nd is the same as 1 over x to the 2nd. See how I'm clucking, big chicken? Okay. It moves it into the bottom. And as we change this number, as we increase that number, this number keeps increasing down here. So I want to show you something. Oh, that's not what I want to do. I'll go over here. This is the graph. Oh, man. Come on. That's not cool. Well, that was going to be the graph. It's going to be a very cool graph. There we go. Okay, so if we look at what 3 raised to any power is, here it is. What you see is that everything on the positive side, all our positive numbers down here, look at that. The graph is increasing. Increase, 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 increase. But over here, it's getting smaller, 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 smaller. Okay? In fact, you can look at this. If x was, let's see, if we raise 3 to the 3rd power, 3 times 3 times 3 is 27. Look at that. There it is. It's right there on the graph. If we raise it to the 2nd power, 3 times 3 would be 9. Look at that. That's on the graph. If we take 3 to the 1st power, that would be 3 by itself would be 3. See how those numbers are on there? They keep spreading out further and or getting closer and closer to each other now. Now, if we take 3 to the 0 power, anything to the 0 power is always 1. There it is. But now if we go to the negative 1, negative 1 is going to be 1 over 3. Oh, gosh. Sorry. It's going to be 1/3. There it is. Or 1 over 3 to the 1st power. And negative 2 was going to be that 1 over 3 squared. So 1 divided by 9. And negative 3 is 1 over 27. There you go. It just gets smaller and smaller and smaller, and it almost follows, see, it follows that x-axis forever. It never quite gets all the way to 0. It says 0, but it's not actually all the way to 0. It's just almost there. It's going to be a really, 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 really small fraction. Okay. So let's see how this works out in actual practice, okay? We're going to solve some of these. These are all ones that we need to simplify. This is like 8th grade math that you should be doing. Okay, so this one, simplify. 2 to the negative 3. That's going to be the same as, oh, let's get me back in a pen. That's the same as 1 over 2/3, or 2 to the cubed. And 2 cubed is the same as 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8. That's our answer, 1/8. Here we go. Okay. Hope that made sense. Now, what's this one? 2 to 0 power is always what number, Ami? Always 1, because we always divide it by itself. 1. Okay. Now these guys, when they put them together, here's what I want you to do. I want you to look at each one. Okay. So leave that 2 alone for a little bit. We're going to leave that 2 alone. What's m to the 0 power? Anything to the 0 power is 1. And n to the negative 4, remember, that goes to the bottom, like that. And now we need to put all this together. We multiply all the tops together, we multiply all the bottoms together. Now, this doesn't look like a fraction, but this looks like a fraction, and that can be intimidating. So what I do is I make this into a fraction too. And then I multiply the tops together and multiply the bottoms together. So 2 times 1 times 1 is 2. And 1 times n to the 4th is n to the 4th. And that's my answer. Okay. I hope you can hear some of the stuff in the background. If you're wondering, I'm sitting outside of a Thunder Road right now while Zika and Eli are playing, and I'm doing a math video. Oh yeah, I'm cool. Okay, now here, there's a negative out in front, but it does not have parentheses saying the negative belongs to that one. So the negative is kind of just hanging out in front. So we are going to do this and this and leave that negative alone for a while, okay? Okay, so the negative goes out front. The x squared leaves, it's a positive exponent, so we leave it on top. And that y to the negative 2 goes on the bottom. Now you can go ahead and do 1 over y squared, or you can just do this too. This is okay. It's going to go underneath there eventually anyways. If you're not feeling comfortable with that yet though, you can do this. 1 over y squared. And then put a 1 over here as well and multiply across the top and across the bottom. So negative x squared times 1 is negative x squared. And 1 times y squared is y squared. And that is our answer. So you can see, let me erase these here, that this just ends up moving to the bottom. Okay. All right. And maybe you can see what's going to happen here too. That you see a negative exponent, so this is going to end up moving to the bottom. But again, this exponent only applies to the m. I'm going to put those parentheses around each part here. That 2 and the m are 2 different things. Okay? So my 2 stays on top. My m squared is going to go to the bottom. And my n squared is going to stay on top. Look, I did that all in one move. I hope you like that. That was pretty smooth. I'm feeling pretty awesome. Okay. If that felt fast for you, you can do it the slow way. You can do 2 times 1 over m squared times n squared. And turn them all into fractions and multiply it all together. That's fine too. This is your answer. Okay? All right, now let's see some tricky ones. I think I have a tricky, okay. This guy, negative 3. The negative 3 and the x are not married to each other. Like, well, that exponent only belongs to the x. If they put parentheses around this, like that, then we'd have to do this. Negative 3x to the third. Oh, that was messy. Like that. But they did not. That's not correct. Wrong. Yucky. So this is its own thing, and this goes together. So the -3 stays on top, and this goes down below. So it goes x cubed. Okay. Okay. This one, tricky. This one, they do put the parentheses around. So we are going to do 1 and over -4 squared. Now, that's the same thing as 1 over -4 times -4, which is a positive 16. Because negative times negative equals positive. This one's tricky. Okay. All right, and this one, 1 over 4 to the third. And any of those with numbers, you can solve more. 4 times 4 times 4, which is 1 over 64. All right. Oh, I got more. Okay, only one negative exponent. We're going to move that to the bottom. -4 and y we're left on top, and x, and it says -1. Once it goes on the bottom, you do not need to put a 1 next to it. Okay? You never need to put a positive 1. The -1 just needed to be there just to tell you that it needed to move to the bottom. Okay. All right, and last one. This one's moving down. So we got y cubed left on the top and x squared on the bottom. All right. I hope those helped. If you have any kind of different problems in your practice, please send me a picture and I will shoot you off a quick explanation explaining more on how it works. Or if any of this did not make sense, shoot me a text or we can Zoom. Love you. Bye, hun.